Alrighty. So we are on notes 2 of 3 in our chapter on proving triangles congruent. In the last set of notes, we looked at side, 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 and side, angle, side congruence. This time we're looking at angle, side, angle, and angle, angle, side congruence. Now, these two methods are pretty much the exact same as the others. It's just different letters we're looking at. So we're going to move a little faster this time. I'm not going to spend as long explaining the proofs. If that's something you're struggling with, let me know. I'm more than happy to help you. But you'll see that a lot of the things we learned last time are also true in this case. So let's dive in. So we're going to start with the definition for angle side angle. Basically, all this is, we're going to call this ASA, congruence. If two angles, and the side between them of triangle 1 match triangle 2, then triangles 1 and 2 are congruent. So, if two angles and the side between them of triangle 1 match two angles and the side between them of triangle 2, then triangle 1 and 2 are congruent. So that's really it. We have angle, side, angle, angle, side, angle. Listen to that little song, angle, side, angle, angle, side, angle. You should be able to play that little song to identify angle, side, angle congruence. So moving down to A, B, and C, go ahead and try real quick to identify angle, side, angle. Pause, and then I'll show you the answers in a moment. Okay, so in the first one we have angle, side, angle, angle, side, angle. This one here is ASA congruence. Whereas this one here is angle, angle, side, angle, angle, side. That is not angle, side, angle. This last one is side, side, angle, side, side, angle. Not angle, angle, side. Not angle, side, angle. So only the first one was angle, side, angle. Again, we can go angle, side, angle, angle, side, angle. So moving down to D, I'm going to do the first proof to show you what angle, side, angle looks like. And then there's going to be 2 more proofs on the back that I want you to do yourself. So we're going to start with the information given, of course. Don't even look at the proof yet. I want you to start by simply doing the picture. So we're told that SQ bisects RQT into RST. That's literally the only thing we got. Now, since this middle line here bisects both of the angles on the other side, we know that the top angle for triangles 1 and 2 matches the bottom angles. So this angle here matches the same angle on the bottom. This angle on the right matches the same angle on the bottom. Both Q and S were bisected, so each of their halves are congruent to the other half. 1 half, 2 half, 1 half, 2 half. Bisected, bisected. So I also know that the middle line is shared, so it's going to be congruent to itself. We have angle, side, angle, angle, side, angle. We have a pair of angle, side, angle congruence. So I'm actually going to start with a proof. I'm going to write my proof down at the bottom. Triangle QRS is congruent to triangle QTS. And why? Well, angle, side, angle. Now that we have our proof down at the bottom, we're going to build up to it by starting with the given. SQ bisects RQT and RST. This is given. Next, I'm going to go with what I got. I know that RQS is congruent to TQS. Angle RQS is congruent to angle TQS. And why is that? That's going to be the definition of angle bisector. We're going to say something similar for RSQ. So RSQ is congruent to TSQ. Angle RSQ is congruent to angle TSQ. And again, that's because of the definition of angle bisector. Now, one thing that you should do while you're doing this, every time you knock out an angle or a side, you should cross it out on your proof below. So I have one angle, two angles. I'm going to cross both of those out. The only thing I have left to prove this, of course, is the middle side. So all I have to do is say QS is congruent to QS. Why is that? Well, reflexive. And then I've knocked out my angle, my side, and my angle, so I'm done. So always do the picture first. That'll guide your proof. As you fill in parts of it, knock out your letters to make sure you know when you're done. Okay, so I want you to take this time to pause and try the proofs on the back. E is kind of tricky. F should not be too bad. So go ahead and try both of those, and then we'll move down to angle, angle, side once you're done. Okay, on to angle, angle, side. So angle, angle, side, angle, they're pretty similar. They have pretty similar proofs as well, or they have pretty similar definitions as well. This one's going to be like so. I'm going to start with calling this AAS. And I'm just going to say if two angles and a side outside of the angles in triangle 1 match triangle 2, then triangles 1 and 2 are congruent. If two angles and a side outside of the angles in triangle 1 match two angles and a side outside of those angles in triangle 2 match, then triangles 1 and 2 are congruent. So we have angle, angle, side, angle, angle, side. So once you got that down, we'll flip it over. All right, just like before, I want you to pause and identify which of these three are angle, angle, side. Give it a second. Okay, so this one was not angle, angle, side. This would actually be side, side, angle. This one will be angle, angle, side. We go angle, angle, side, angle, angle, side. This one's also angle, angle, side. Angle, angle, side, angle, angle, side. Okay, so we know how to identify angle, angle, side. It's time for us to do one more proof with it. So I'm going to do one. There's three more. Once you've got all three done, you'll be set. Let's do the example. So we're told, I'm going to do my proof later. I'm just going to do the picture for now. YZ bisects WYX, and then YWZ is congruent to YXZ. So these two are congruent here, and we're also told that this line in the middle bisects angle Y. So it has two halves, and these halves are congruent. I also have my shared middle line, which means I can go angle, angle, side, angle, angle, side. Okay, so I have angle, angle, side congruence, and I'm always going to start with my proof at the bottom. We always start with our proof. We got to know where we're going before we go there. So we know that YWZ is going to be congruent to triangle XYZ. The reason why is angle, angle, side congruence. Okay, let's start with our givens. We're told that YZ bisects angle WYX. This is a given. Next, we're told that angle YWZ is congruent to angle YXZ. This is also a given, and it knocks out one of our angles right there. So we'll be done when we have one more set of angles and one more set of sides. I'm going to do my angles next. Since this was a bisector, I know that the two parts of y are congruent. I can say angle WYZ is congruent to angle XYZ. This is because of the definition of an angle bisector. Lastly, we know YZ is congruent to itself. And this is reflexive property. So we've knocked out one more angle, one more side. We've knocked everything out, which means we're done. So we have 3 more examples that I'd like you to try. There's one on the bottom, and then 2 more on the back. Remember, do your picture first, identify which method it's going to be, and then do your proof. So building up from here, we have 4 methods. We have side, 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 angle, angle, side, angle, and angle, angle, side. In the next video, you're going to learn the final method, which is called hypotenuse leg. But I'll take a moment for you to know that the methods that don't work are angle, 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 and side, side, angle. We'll look briefly at y in the next video. But just know for now that these are the only 2 methods that don't work. Everything else does. Another way we can write angle, angle, side is also going to be side, angle, angle. And the reason why is because, let's say we look at our definition picture here, we can read this as both angle, angle, side, and side, angle, angle. It's just in the opposite order. So, as always, let me know if you have any questions at all, and thank you very much.